Now, so what we should remember is that the total internal reflection has two basic necessary conditions. Okay, right here. Conditions for total internal reflection. So the first condition is that the light must be going from a more dense medium to a less dense one. Okay. And the way you can actually tell that is by comparing ends. So suppose that if these are two mediums, right? And the light is going like this, it would only come back theta 1 and theta 2 like that. It can only come back if the refractive index of this medium is greater than this, right? So it means n2 should be greater than n1. All right, Ikra?
Yes.
The other thing that is absolutely necessary is that the angle of incidence must be greater than angle of critical angle. So that's very important. Obviously, these two angles, when it reflects, right? So it will follow all the rules of reflection. So you should remember, theta 1 will be theta 2. In any case, right? These angles are same. Now, so we also need to, there's a core practical where we need to learn how to measure the refractive index, which is very simple, and we're going to do it right away. So core practical, measuring refractive index. Okay, now, so what you need is, you need a piece of paper, and then you need something like a glass or perspex. Perspex is just, another sort of it's a clear plastic white perspex block. And then what you need is you need it's called a ray box. Ray box is just laser light. So when it enters like here, so within the perspex you can see the light going in and then going out like this. You'll see that. Okay. Then what you need is you need to draw a perpendicular line like this. Perpendicular line drawn using a pencil. That's what you're gonna do. Now, so now let's move to the variables. First of all, we should remember that the dependent variable is the one that changes if we change the independent one. Would be obviously the angle of refraction, or, and then we have the independent variable that we can control, which is angle of incidence. Obviously we can move the ray box to control this, and what you need to keep constant or control variables must be like use same perspex block. So you should always do that for different for different values of I. Keep same width of beam, so that you get the same result. And you also need to keep the same wavelength of light. Should not change that, obviously, because different wavelengths and frequencies were basically bent differently. That's why. Okay, Kra, do you understand this?
Yes.
Good. Now let's see what you get. So the method to do this is that place the perspex block and a sheet of paper on a sheet of paper, and draw, in fact, trace its shape around it using a pencil. That's what you want to do. Then switch on the ray box and direct a beam of light at the block, right? Like this. Then mark using a pencil number 1, point close to the ray box. Like, what I'm saying is, wherever it's going, right, you can mark it like X here. Then number 2, point where the ray enters the block. Like, you can put it here. Then point where the ray exits the block. And fourth, point a bit far away from the point where the ray exits. Okay. Like, what you need to do is, where it's coming out, point really close and then a bit far. Alright. So if I say,
Yes.
yeah, so you're marking the path of this. And then what you're going to do is, that because you've already traced it, right? So when you remove this, it will just look like this, you know. So when you remove this, it is going to look like your glass block, perspex. So you've traced the thing, and now it looks like this. And also you got, points made like this. Okay, now so now what you're going to do is, you're going to take the ruler and a pencil and connect these points like this. Like this, and then like, okay, first you need to connect the other one like this, and then connect these like this. All right.
Yes.
Yeah. Okay. Number one, draw two lines at the entry and exit by connecting them to points labeled X, like we have done it now. And then what you're going to do is join both ends with another line, okay, like that. Then repeat the same process with different angles of I. So how do you find angle of I? You're gonna basically draw a perpendicular line here. This will be angle I, this will be angle R, right? And you can take multiple angles like this. So you're taking angle of incidence and angle of refraction, okay? And you can keep on repeating this, right?
Yes.
What you should remember, at the end of this, there will be three conclusions. Obviously, you can use n1 sine 1 theta 1 equals to n2 sine theta 2 to find refractive index, right? And because you're doing it in air, so air n is always 1, so it will give you of the glass, get measured with protractor. But the conclusions are that at the entry point, angle of I is greater than R. Then at the exit, angle of I is always less than R. Like here, it should have bent the other way, but oh my god, the diagram is a bit shaky, sorry. Need to make it again. Make the diagram first and then I'll mark it. Yep, now it's correct. Okay, so this is I, this is R, this is I, this is R. Okay, so that's why I've written this. And also, one thing that you need to understand is that when angle of incidence is 0 degrees or 90 degree to the surface, it's the same thing. The ray does not bend. Which means that if the light was going this way, like it was this way, then it would just go straight. If it's coming 90 degrees to the surface, it would not bend. Okay? Is that clear, Ikram?
Yes.
Good. Now, some of the things that you should always remember. In experiment, they might ask you about safety considerations. In Unit 3 especially. So what you want to do is, you should remember that ray box may get hot and might cause burn. Alright, so you should remember this. Usually we got to use gloves when handling. Then the laser light that comes out of it may damage eyes. So always stay behind the ray box. Do not, come directly in front, or do not look at the ray directly. That might cause injury. Okay, I hope that's clear now.
Yeah.
Have you written everything? Is there something that is left? Please let me know. I can go back to that point.
No, it's done.
Alright, very nice, Sikra. Now, the next thing we're gonna do is called intensity. So intensity is defined as power per unit area. Intensity has a symbol I. This is power over area. And intensity SI units are watts per meter square, like that. Sometimes we also use intensity, like intensity equals to energy over time over area. So this formula is also used sometimes, because power is energy over time. So that's how sometimes. Now, intensity has three different relationships, okay, that you must remember. So the relationships are that intensity is directly proportional to amplitude square of a wave. Intensity is directly proportional to square of a frequency, and intensity is inversely proportional to distance from the source where the wave is coming from. Okay. Now, so what you need to remember is, suppose that there is a wave like this. Okay, let me make it a bigger one. There is a wave like this that has amplitude of A and intensity I. Okay. Now if somehow we double the amplitude, keep the frequency even the same. Now this one has 2A amplitude because intensity is proportional to amplitude square. So we can say intensity will be increased to 4 times. Alright, understood?
Yes.
Now, between comparison of two, there is a very simple formula that you can follow. That would be I1 over I2 is equal to amplitude square of the first one, amplitude square of the other wave if you're comparing two different waves and their intensities. Understood?
Yes.
Now in terms of frequency it is the same thing. So you have a wave like this and then you increase the frequency such that if the frequency of this wave was f and intensity was I, and now this has 2f, so intensity is going to be 4 times I. It's a square as well. So obviously you can create a relationship. I1 over I2 will be equal to f1 square over f2 square. So this is just intensity of two different waves when you compare them with respect to frequency. Okay. Then comes intensity with respect to distance. Now this is pretty easy. What you should remember is that suppose if this is the source, in fact let's make the source here. If this is the source where the light is coming from, so light basically spreads evenly like this. So if you're looking at a certain distance till this point, so actually from this to this distance, as you can see that more light will be on this one, but as you go further and further, like if you go twice the distance away, then obviously the light is going to spread even more. So the area is getting bigger, which means intensity is getting smaller. So at this point, if the intensity is I, then at this point it will be I by 4. The reason is that they are inversely proportional to the square of distance. Is that clear?
Yes.
So now if I want to create a formula, it would be I1 over I2 now will be R2 square over R1 square. So as you can see, the main difference between the other two and this one is that I1 was right up against F1, here I1 was right against A1. In this it's opposite, I1 is against R2 and I2 is against R1. Alright? It's flipped because they're inversely proportional. Got to remember that. Alright, you can write this please, and then we'll do a question.
Done.
Okay. In this one, sometimes they give you rounded objects like spheres or something. So, just a tip that the surface area of a sphere is given by 4 pi r square. So you should remember that, okay? So a lot of times they will give you this, and I don't want you to, even if you don't remember from, okay. Now in such question, it says the intensity of a wave shown is I. Alright. Draw another wave with intensity of 2I, like that. Okay. So they have given a wave here. Intensity 2I of same frequency. Okay, so they've already written the frequency same. Now it has an amplitude A1, and this is the displacement on this side, and this be the distance. Okay, let's suppose. Alright. Now Ikra, if I ask you that what would be the amplitude of the wave that has an intensity double of the first one, can you please find that?
Will it be 82?
82?
No.
Yeah, what?
A2.
No. No. If this is, let's suppose this is A, right? So the relationship is I1 over I2 equals to A1 square over A2 square. So the first one has intensity of I, and the second one has intensity of 2I. Alright? The first one has amplitude A square, the other one has an amplitude of A2 square, so we need to find this A2. So I and I will cancel out, it's going to be half equals to A square over A2 square. So A2 square will be equal to 2 times A square. You take under root on both sides. So A2 will be equal to under root 2A. Do you understand?
Yeah, I got it.
And obviously under root 2 is greater than 1. So we're going to pull out the calculator. We're going to say, okay, under root 2 is 1.4. So it's 1. Oh my goodness. It's 1.4a. So 1.4 will be like a bit, bigger, like there. So now because frequency is same, it's going to be a wave with a larger amplitude, obviously, than before. You would trace it like this. Do you understand? And you don't have to change the frequency. The reason is that frequency in the question is the same. Alright, Ikra?
Yeah.
Alright.
Yes.
Good.